bracket AP review. This is 2010 Form B, AB, BC, free response 1. In the figure drawn here, but also way better on the real AP paper, R is the shaded region in the first quadrant bounded by the graph of y equals 4 natural log of the quantity 3 minus x, the horizontal line y equals 6, and the vertical line x equals 2. Part A, find the area of R. So this is the line y equals 6, right? And this is the curvy thing, the 4 natural log of 3x, or 3 minus x, right? So I called the curve y1 in my calculator, and I called the 6 y2. You don't have to. You could just call the 6 a 6. It's probably just as easy. So I don't need to find the bounds in this problem because I know that the bounds go from x is 0 to x is 2. I really just have to do top curve minus bottom curve. So I'm going to show the setup of that integral, right? I need to show exactly what is inside the integral, and then type, and the calculator does it for you. So I'm integrating top curve, which is 6, minus the bottom curve, which is the 4 natural log of the quantity 3 minus x, with respect to x, from the start, which is 0, to the end, which is 2. Right? And then type, and my calculator does it for me. So when I put in my calculator, I'm going to put in my calculator as math 9, which is function integrate, 6 minus y1, right? That's a lot easier than bothering to type the whole thing all over again, but it's probably not worth my time to get y2 out of the vars section of the buttons. I might as well just type a 6 because it's a 6. With respect to x, from 0 to 2, and then boom, it's going to give me an answer. So just to show you, I did put y1 and y2 in together, but again, the 6 makes more sense just as a 6. So I'm going to go to math 9, right? So math 9, right? I'm going to go to, I'm going to do 6 minus, and then I'm going to go to vars, over to y-vars, pick function and pick y1, comma, with respect to x, from 0, comma, to 2, right? And there's my answer, and I should get a 6.816 or 817, depending on if you round or truncate. So 6.816 or 7, depending if you round or truncate. Again, that's not worth a lot, right? You are making sure your integrand is correct, and then typing. Part B, find the volume of the solid when R is revolved about the horizontal line y equals 8, which is why I tried to draw my graph a little bit lower here, but we'll see if that pans out. So I'm now revolving around the line right here, ish, give or take. This is my axis of revolution. It's where y is 8, right? If I revolve around that line, what's going to happen is I'm going to take some arbitrary slice somewhere in the middle. I take this little slice and I revolve that slice around. So I'm going to end up with this open circle in the middle, and then each one of these revolutions is going to look like an annulus or a washer, right? So in other videos, we've talked about the way you find the area of a washer, right? If you have an annulus or a washer, right, meaning a circle with a circle cut out of it, right? That's the big circle minus the hole that was cut out of it. So that's why it's pi big R squared minus pi little r squared, or if you factor the pi out, it's big R squared minus little r squared. The squared's never on the outside of the r minus r because that would be a different quantity, right? So once I know that, my job is primarily just to figure out what the r values are. So again, not r as in the shaded region, r as in the radius. So the big R is going to be this top curve, which in this case is the blue line, the axis of rotation 8, minus the bottom curve. So my big radius here is going to be top curve 8, like the top of this line, right, 8, minus the curve at the bottom of this thing, which is the 4 natural log of 3 minus x. My little radius is going to be this axis of rotation minus the curve that's closer to it, which is really an 8 minus a 6. Just to point out, the AP doesn't even write 8 minus 6 is 2. They leave it as 8 minus 6. Don't make your life harder. So if the area then is pi this big R squared minus this little r squared, the volume, so my answer to part B, is going to be the integral from 0 to 2 of that pi big R squared, and you're not going to clean it up. You're just going to leave it as this whole big R in parentheses squared minus, and the little r I would leave as 8 minus 6, quantity squared with respect to x. This is what they want to see for the setup on your AP. And then you're typing and giving them an answer. When you type this in, right, the way it's going to look in my calculator is pi, right, and then I'm going to do function integrate, which is my math 9, in parentheses, right, I'm going to do 8 minus the thing I called y1, quantity squared, minus 8 minus 6, quantity squared, with respect to x, from 0 to 2. That's what I'm going to have to type in, right? Again, the AP is not going to give you any credit for this, but if you don't know how to do it, that's a problem. A lot of times we forget the pi. I've had several students remember that at the end of a calculator section, you still have the calculator problems. You just can't use a calculator. So, or at the end of the calculator free response, rather. So I've had students that have realized after the fact, oh no, I did this, I wrote it all down, but I know I forgot the pi. And they've just cheated and tacked a pi on at the end when they no longer had a calculator, and it's the right answer. So, but, try to be cautious that you double check you put everything in right. So I do my pi, I do my math 9, right? And then in parentheses, I want 8 minus vars over to y vars, pick function y1, close that, quantity squared, minus 8 minus 6 quantity squared. And again, if you just want to make it a 2 squared, you can, but, it's not necessarily worth it. With respect to x from 0 to 2, right? And I hit enter. So I get a 168.179, so 168.179 or 80, right? But I want to point out that the other option is, let's say you accidentally screwed up and you forgot the pi. So I'm going to hit second enter for a sec and show you what would happen if you screwed up and forgot the pi. Or maybe you just didn't want to put the pi there. I could do this without the pi. I'd get 53.33, or 533. If I had done it without the pi, I would have gotten 53.533, and I could just leave a pi next to it, right? It's still approximate because this number is still approximate, even though the pi is still a pi, right? So I just want to point out that, if you realize, oh no, I forgot the pi, you could go back and be like, oh, I see what I did. And I've had students save the day for themselves at the end of a test on this, where not the AP, I don't see them when they take the AP, but on the end of one of my practice exams or one of my questions, where I'll see them have this moment where they think, oh, no way, and they flip back to the calculator, write a pi down, and sometimes they'll even write me a note that's like, oh man, I think I forgot a pi. And then I will put a note that says, yeah, you saved the day, man. That's pretty impressive. So just be mindful of that stuff. Finally, part C, the region R is the base of a solid. For this solid, each cross-section perpendicularly x-axis is a square. Find the volume of the solid. Okay, so I'm going to redraw this graph just because it's kind of seen better days. So we're looking at this, and also this is not the worst of these graphs that I've ever seen. So we're looking at this region. That's not perfect, but it is what it is. And what they're saying is perpendicular to the x-axis, there are these little cross-sectional squares. So the cross-sectional area problems, I always say it's kind of like you have a dish rack. You have a dish rack where you have all these dishes, and they're square dishes, right? And there's dishes of different sizes, but there's all these square dishes, and they all stand up this way, and you want to find out the volume of this shape, right? So in order to do that, just like we did with everything else, we need to find the area of each one of these cross sections. So one of these cross sections, right, I'm going to call this S for side length, right? S is going to be top minus bottom. So the side length of this square is going to be top, which was 6, minus bottom, which is the 4 natural log of the 3 minus x. Well, the area of a square is side squared. So that means that the area of this thing is 6 minus 4 natural log of 3 minus x, quantity squared. And the volume is going to be the sum of all the squares. So integrate from 0 to 2 of this quantity, right? So the 6 minus the 4 natural log of the quantity 3 minus x, whole quantity squared with respect to x, and then you're going to type and make your calculator do it for you. So when I put this in my calculator, right, the way I'm going to put this in my calculator is function integrate, in parentheses, a 6 minus y1 quantity squared with respect to x from 0 to 2, and then it's going to give me that answer, right? So I'm going to do math 9, right? In parentheses, 6 minus vars over to y vars, pick y1 quantity squared with respect to x from 0 to 2, and then I hit enter, and I get the 26.266 or 267 that they want me to get. So 26.266 or 67, depending on if you round or truncate, and that's my answer.